You have probably heard of the most famous cat in history. It is locked in a steel box with a vial of poison, and until you open that box to check on it, that cat is technically both dead and alive at the same time. This is the story of Schrödinger's cat. For decades, we treated this idea as a simple thought experiment, or maybe just a joke about how weird physics can get. But what if I told you it is no longer just a theory? What if the boundary between our reality and the ghostly world of quantum mechanics does not actually exist? We used to think there was a strict limit. We thought quantum rules applied only to tiny atoms, while you and I lived in the real, solid world. But recent breakthroughs have shattered that assumption. Scientists are now proving that massive objects, things visible to the naked eye, can actually exist in two places at once. The implications are absolutely terrifying. It suggests that reality itself might not be real until you actually look at it.
Let's back up for a second to understand the problem. In the quantum world of atoms and electrons, the rules of logic simply do not apply. A single particle can spin clockwise and counterclockwise at the exact same moment. It can be in New York and Tokyo simultaneously. Physicists call this state superposition. But look around your room right now. Your coffee cup is not floating in two places. Your chair is not vanishing and reappearing. In our everyday lives, things are stable and boring. So where is the line? Where does the magic stop and regular life begin? For 100 years, physicists believed in a barrier. They thought once an object got big enough, it lost its quantum magic and became classical. Erwin Schrödinger actually created his cat analogy to show how stupid this idea was. He wanted to prove that applying quantum rules to everyday objects was absurd. But nature had a surprise waiting for us. It turns out Schrödinger was wrong about his own joke. The absurdity is actually real.
This brings us to the massive breakthroughs that have dominated physics discussions recently. We are no longer just playing with single atoms. Scientists have started building their own versions of Schrödinger's cat, but they aren't using animals or poison. They are using superconducting circuits. Imagine a specialized computer chip. It contains billions of electrons moving together. According to the old rules, this is way too big to act like a ghost. It should be solid. It should be predictable. But by cooling these chips to near absolute zero, researchers forced them into a quantum state. They made billions of electrons flow left and flow right at the exact same time. This isn't just a mathematical trick. It is a physical object, something you could almost touch, existing in two contradictory states simultaneously. The invisible wall between the quantum world and our world is crumbling down.
So why don't you see this happening on the street? Why don't cars blur into two lanes at once? The answer lies in something called decoherence. Think of the quantum state as a very shy ghost. It can only perform its magic when absolutely no one is watching. But watching doesn't just mean a human eye. The environment itself is constantly watching. Light particles bouncing off an object count as watching. Air molecules hitting a surface count as watching. Heat radiating from a body counts as watching. Every single interaction with the outside world forces the object to choose a single reality. It collapses the superposition. This is why we don't see quantum effects. We are constantly being bombarded by the environment. The universe is essentially bullying us into being real. But inside those frozen, isolated labs, scientists have managed to silence the noise. They created a space where the universe isn't looking. and suddenly the impossible becomes possible.
This leads us to a disturbing question. Does the moon exist when you aren't looking at it? It sounds like a question for a stoned philosophy student, but it is actually a serious physics problem. This concept is called macroscopic realism. It is the belief that objects have definite properties whether we observe them or not. If a tree falls in the forest, macroscopic realism says it definitely makes a sound. But quantum mechanics disagrees. It suggests the tree is in a superposition of fell and didn't fall until something interacts with the sound waves. For years, we thought this only applied to atoms, but thanks to work related to the 2025 physics discussions, we are testing this on a larger scale. We are finding that realism might be an illusion. The data suggests that objects do not have fixed properties until they are measured. We are not just discovering how the world works, we are discovering that we might be creating it.
So what happens next? We are rapidly scaling up these experiments. We have moved from electrons to molecules. Now we are moving to mechanical vibrations and mirrors. Some physicists are even proposing experiments with living viruses and bacteria. Imagine a living organism existing in two places at once. It sounds like science fiction, but the math allows it. The only thing stopping us from putting a human into a quantum superposition is the technical difficulty of isolating a person from every single heat wave and air molecule. But in principle, there is no law of physics that says you cannot be a quantum object. You are just a collection of atoms after all. If we can isolate larger and larger things, we might eventually prove that the entire universe is just one giant quantum wave function.
This brings us to a profound conclusion. Schrödinger's cat is no longer just a paradox. It is a glimpse into the fundamental structure of reality. The boundary we thought protected us from the chaos of the quantum world was never really there. It was just a result of our messy, noisy environment. We are living in a universe of infinite possibilities, constantly collapsing into single moments because of our interactions. In a way, the future is not written in stone. It is a cloud of probabilities waiting for an observer. Every time we interact with the world, we are essentially opening the box. We are forcing the universe to decide what is real. And that makes you, the observer, the most important part of the equation.